Thank you.
Everyone.
Oh, sorry. Thank you, Ms. Sudha. Thank you so much for coming and um, speaking to us. So I'll just give a quick intro and then I'll hand it over to Ms. Sudha. So Ms.
Thanks,
Sudha
Dia.
Diliraj works with Amazon Web Services, and she's an IT professional with 15 plus years of experience in systems, networks, and virtualization. Today we have her here to speak on cloud technology and share her experience. So thank you for joining us, and over to you, Ms. Sudha.
Thank you, Dia. Hello, everyone. Good morning, good afternoon, good evening. Depends on whatever time zone you all are in. I have no idea where you're all from. Um, I'm not able to see you, but I don't know if I can talk to you. Dia, can I talk to them? Will I be able to hear them?
Not really, Auntie, but if they text on the chat, I can let you know whatever they say.
Oh, really? Okay. All right, cool. So I will just assume that you're all listening to me and I'm going to start presenting. Today, as Dia was just mentioning, I want to talk to you about cloud technology. I'm pretty sure most of y'all or have heard this term cloud many times. And some of you all will probably have an idea about what exactly it is as well, right? This From this guest lecture, what I want you all to understand is uh, to have a good foundation about what cloud is, and I want to take you through the transition about how the systems were from the pre-cloud world to the cloud, right? So I want to take you through the journey of it. And I will also talk about today what cloud represents and what kind of applications users are using cloud for, right? I will get started. I'm hoping I can share some slides that I prepared. Let me try to do that. If there is any feedback, do put your questions to Dia. Probably Dia can share it with me anytime along the way.
Yeah, I'll do that.
All right. They are able to see my PowerPoint.
Yeah, we can see it.
All right. Okay. To start with, right? Like, what are the when we talk about computers, we all know we're all very familiar with computers. We use it every single day. Uh, what are the building blocks of computers, right? Just starting it from the scratch, from the base. So as we build on top of it, you get a good understanding of it. So when you talk about computer, the main building block of a computer is the compute itself. You call it a CPU, call it as processor. That is the main building block that does all the processing for the instructions that you ask it to do, right? Like process. And then whatever data it is working through, it needs a place, right? Like to keep it where it will take fetch data from somewhere, work through it, and it needs a space where it can keep them in a temporary basis, and that is what we call it as memory, right? And then storage is also another integral part of computing, because whatever we're talking about, the memory part, it is it is ephemeral in the sense that when the computer goes down, everything gets erased, so there is no data for you to go and refer back to, right? So storage is a permanent area where whatever processing you've done, your results, your inputs, whatever data you have, you need to put it in some permanent area space, and that is storage. Hard disk, you all know what a hard disk is. So that's exactly where it's stored. So what we are talking about is just one single computer. And how do you interact with the computer? You need some kind of input output devices, and the very basic type of input device is a keyboard, mouse, and we have a lot of other devices that you know of. And output is whatever the processing is spitting out. It needs to give it to the end user, right? So monitor, printer, these are all different types of output devices. So this is a very basic building block of a system. Now, how things work. So we are going from one single computer, and we are visualizing how the entire client server network along with internet is all coming into picture. So this is all pre-cloud times. So we used to have something called, every computer that you work with, there are actually two types of computers, right? So that is again another basic terminology. You call some as servers and some as clients, and it's very simple, right? Servers are something that provides you with some service. It could be a file server, it could be a mail server. Uh, Service is nothing but it provides you with some kind of service. And when you say client, they are all using those services. As a user, when you sit in front of a laptop or any iPad or whatever kind of end device you're using, you're actually using a client, right? So it is all the processing or all the services that you're trying to access is sitting on the server. So as you see in the picture, right, all these servers and clients and everything, they need to talk to each other, right? How do they do? It is all through networking. We're not going to go any deep into that, but you should know that these are all connected through various types of networking devices like switches, routers. You've heard about all these terms, I'm sure. And we have all new kind of technologies, how these connect. There is fiber optics, there is Ethernet, there's different types of connections that you can use to actually make this network possible, right? We have all of these, great. So this is an office kind of environment. The users come in, they sit on the clients, they use the servers, the applications are all running on the servers, they're accessing it, great. But that's not enough, right? So we have this big band called internet. That is exactly how you are going to reach out to every single user across the globe. So internet is the big part. So you need some kind of way to connect to the internet. So that is exactly how there will be edge router of some sort in every physical office, and that kind of connects this on-premise network to internet. So this is how a client server network typically looks like before the cloud area. Now, what is the foundation for cloud is something called as virtualization. So in this particular, whatever we just discussed about, there is going to be one, you have a computer hardware, there is an operating system that sits on top of that computer. Let me take another picture. Yeah. This is all my handwritten beautiful diagrams. So you have a computer hardware at the bottom, your operating system. You know what an operating system is? It is nothing but something that directly interacts with your hardware and the applications that sits on top of it. Windows, Linux, all these are different flavors of operating system. So on the left hand side, whatever you're seeing is something that is what a typical computer is, right? What is virtualization? Why we need virtualization? So in the left hand side, the typical computer system, this was working fine, right? The initial days we had servers which were like, okay, they were not supercomputers. The technology itself was not so great, so everything was fine for that era of time, right? But then what happened was, during the time, there was a lot of innovation that happened in the semiconductor industry. This, like, Intel is one of the biggest vendors who creates these processes. There's a lot of innovation that happened. So they started generating these very powerful, highly sophisticated systems. So running a single or couple of applications, or just running one operating system on top of this particular hardware, is highly inefficient. That's how it evolved, right? At some point, what everybody was thinking is, we're not efficiently using the hardware that we are procuring. It's not, just running a single operating system is not going to give us the efficiency that we need. So that's when people started thinking about virtualization. What virtualization does is kind of abstracts the hardware from the applications, right? Like whatever software is sitting on top of the hardware, it completely abstracts, or it kind of hides it. So what do we get? We can run as many operating systems as you want on top of that, hardware within the same physical box. So that is what you get, right? Like, that is something called, there's different types of virtualization available. The simplest form of virtualization is something called as compute virtualization, or you also called as server virtualization. So what happens is there is a thin layer that sits on top of the computer hardware, as you see on the right hand side. Between the operating system and the computer hardware, you have a thin layer of abstraction created, which is called as an hypervisor, right? What it does is, as I said, exactly like it completely hides the underlying hardware from the operating system. The operating system does not know anything different in this case. It still thinks that I'm talking to the computer hardware, but actually not. So this hypervisor gets all the commands that's coming from the operating system. It kind of queues it, and then the whatever hardware is in beneath it, it is going to share the resources. It's going to queue and have these hardware resources serve these commands one by one in a queue format, right? So that's exactly what a hypervisor does. What it gives, obviously, as you can see, you can run many different operating systems on top of this, not just operating system. When we talk about operating system and application, as if you put it in one bubble, it is nothing but a virtual machine. So that's when the concept of virtual machine comes in. So, so we just talked about server virtualization. I'm just going to touch upon another type of virtualization called network virtualization. This is also important because most of the private and public cloud that we have today has something called a software defined network, and this is the driving power beneath it is network virtualization, right? So we talked about something where we had multiple servers, clients, everything connected in a network through switches and routers, and we have computers connecting to it on the left-hand side, right? So the three different layers within a computer, if you see, you have the hardware at the bottom, operating system sitting on top of it, and then application. This is exactly how it looks, right? Now, computer 1 talks to computer 2 or computer 3 through the network beneath. This is, when I say network, it includes everything, right? Switches, routers, any kind of network device, it is all in that green box below. So this is how it looks without the network virtualization. When we talk about network virtualization, like hypervisor, we have another thin layer that sits between the computers and the network itself, right? And that is, we call it as an software defined network, which is nothing but network programming done in software. That's it, nothing more than that. So that sits in between. And now what happens is these computers does not get to talk to the network directly. They do not know. They don't, the whatever IP addressing or whatever that's happening on the network layer is not directly exposed to these computers. Whatever the software defined network provides these or shows or exhibits, this is how your network is. That's what the computers will see. So this is another important concept of virtualization. Now, going back to the first slide I had to show you. So the virtualization is a process that allows for more efficient utilization of the physical hardware. That's exactly what we just said. And it creates an abstraction. So there are different types of virtualization. We talked about server and network. There are also other types like storage and desktop virtualization. Most of you would, might know about desktop virtualization. We talk about VDI and workspaces and all these stuff, right? Where you really do not have anything on your own laptop. You just click a link that pops up a client environment for you, and you start working on it. And then you close that particular window. That's it. Whatever you're done, it is all getting stored elsewhere, not on your computer. So this is providing you something called as desktop virtualization. So different types of things there, right? Now, what is the benefit of virtualization? We talked about it already, right? For the first and foremost is consolidation. So today you're not buying one physical hardware and you're not running just one operating system on top of it. That single physical box will be running like 40, 50 servers within the same. So you're consolidating. The space that you're occupying is very limited in a data center. Resource utilization. Another, as I said, right, like we have highly sophisticated hardware today. just running one operating system it's not going to completely utilize all the resources beneath it. You probably will be only utilizing 30 to 40% or even less. I'm saying like during peak, you can only utilize that much, and if not, you might be utilizing just very less. So when you are providing this virtual environment by running multiple operating systems, you are able to utilize the resources efficiently. Cost savings, obviously, because one physical box is running multiple servers. Energy efficiency, again, because you're not running multiple physical servers, so you do not need multiple power units and anything. So there are a lot of other things. Energy efficiency management, right? It makes it very simple too. You don't have to buy, you don't have to patch like 100 physical servers. You may be patching just 10 physical servers there. So there is a lot of benefits. Resource allocation. You're able to share whatever resources you have in the way that you want. You create a resource pool, you put all the physical resources in there and carve out the way you want to different physical machines. So these are benefits of virtualization. We talked about this, just a view of it. You have all these physical functionalities that is all getting compacted and running on one physical server. What is private? So we talked about virtualization, and how is this related to cloud? Is this both the same? Today when we say cloud, right? Just the word cloud, it means public cloud, not private cloud. Okay, we will talk about public cloud soon, but there is when you have all this virtualization, you have all these servers running in one data center. You're providing this virtualization service to the employees of your own organization, right? Let's say that's what you're doing. That is nothing but a private cloud. Cloud, the terminology cloud is nothing but anything that your hardware, software, you're accessing elsewhere, not from your own laptop, it's sitting elsewhere, and you're connecting to it through internet. That is what cloud simply means. But without virtualization, cloud is highly inefficient, right? What is the point? You run an internet, instead if you put everything in your own laptop, it will run great. Why do you have to do that? So virtualization is the backbone or the foundation, or I should say the power engine for cloud technology. So we should know that. So we talked about private cloud. It's nothing but one organization is having a data center or a group of data centers running hardware and having virtualization, everything, virtualization at the layer of compute, network, storage, everything running together, and this service is offered to the employees of the same organization. That is private cloud, as simple as that. Today, there are private cloud providers, multiple private cloud providers available. VMware is one of the leading private cloud provider, and then you have HP, Dell, Microsoft, IBM, Oracle, and many more. These are different vendors who are providing the private cloud as a service. This is a picture of a data center. I don't know how many of you all have been to a data center. So just a picture. So as you can see, right, these are all different racks or nothing but servers sitting there. And you can see, all these servers are cabled. That's how they network. All right. So we now know, like starting from a basic system, how you can create a virtualized environment and offer that to your own employees and then get a lot of benefit. We talked about all the benefits of having a cloud powered by virtualization. Now, as I said, like when you simply say cloud without saying private cloud, it typically means a public cloud. And that is exactly what we're going to talk for the rest of the session. I think I just mentioned this. Cloud computing means storing and accessing data and programs over internet instead of your own computer hardware, and it is powered by virtualization. And we also talked about what is a private cloud. When these services are offered by you to your own organization, it is a private cloud. Now let's go to public cloud, and that is the topic of our discussion today. All right. So you're doing this, right? There is still a lot of inefficiencies they observed even on a private cloud environment. So let's say you have a data center. You're buying about 50 physical servers. You're doing virtualization. You're making sure everything is your resources are utilized in the best way possible. You're doing everything, but let's say your company wants to start a new project, right, or a new business, and they are saying that I want more compute capacity. I mean, whatever you have is not enough, right? So they reach out to their system administrators, network engineers. They say this is what we want, and what they will do is they need to order maybe another 20 physical servers, right? For the time you order, you put your order, your physical servers come into your data center, you start connecting it, and then they start plugging in their application. It's going to take a long time, right? There is no elasticity. Elasticity is on demand. On demand, when you say like, okay, I'm going to do a project today, tomorrow I should be able to start spinning as many servers as I want. That is not possible with private cloud. There's a lot of other things, but this is probably one of the most important thing. Elasticity is one. We'll talk about other things, but this is one of the reasons why these business of public cloud come into picture. What is public cloud is...
Miss Sudha, sorry to interrupt, but the face cam is blocking the slide for the people watching in Google Meet.
This
there should
one?
be like
Okay, all right. How do I close it?
Yeah, now they say
better?
Yeah.
Let me try to move it as... Okay, all right.
Yeah. Thank you.
No problem. So we were talking about public cloud, right? So they see these inefficiencies, and they thought we should do something about it. The business of public cloud came where one vendor, let's say, right? As you see, look at the bottom picture. You can assume like these are all data centers. This group of blocks you see. Let's say these are like 5 different data centers connected to each other, right? Let's say this vendor is creating data centers in one area, and then they're creating in one city, let's say, and then they're creating another group of data centers in another city, and then in another state, and then probably in another country too, right? Like they're creating these group of data centers everywhere, and they start connecting these everywhere. So they have this enormous amount of resources, or I should say infrastructure that is available, that now they can allow other companies, they can come and use it in a shared model, right? In the private cloud, the organization whoever is building that particular data center or the infrastructure, they're offering it to their own employees. But in public cloud, what is happening is it is offered as a service. The vendor creates a stretched network environment, and then they start offering it as a service, as a pay as you go service. So that exactly what is public cloud. Okay. You are running, you're able to run applications, you're able to access software sitting elsewhere, connected to internet, and it is powered by virtualization. But also you do not own any of that. All you have to do is you have to worry about your own application, your own development work that you need to do, or your own business, whatever you need to run. You have to only worry about that. You don't have to worry about anything around the infrastructure that is driving the whole thing. That exactly what is a public cloud. What is the advantage? We talked about it. Agility. Agility is nothing but the speed in which you can start doing anything, right? In IT industry, as I said, right? Like we gave an example about where today you decide that you want to start a new business or expand your business or expand your footprint. At that point, within in the previous case, we would have waited for about 3 to 4 months for all the hardware to come and all the connectivity to happen and all that stuff. But in this particular case, it is just a matter of hours. Within the matter of hours, you can spin as many number of servers that you want, and you can quickly start your business, kickstart your business, and start making your money, right? So that is one important thing. The next is cost savings, obviously, because you're getting into a pay as you use model. Okay, you don't have to in the data private cloud or in the old data center model, whether you use or not, right? The server, you procure the servers, it's going to be there in the data center. Even if you don't use it, it is still going to be there. You still or have already paid, or you're still paying for that resource. But in the public cloud, it is not the case. You can say like, oh, I need this virtual machine for probably 3 hours for doing something. Or you can also do something like, okay, every day for 1 hour I need to do some computing. Okay, every day for 1 hour I need a VM. That's it. And you only pay for the time that you're using VM. So that is the biggest advantage here. Elasticity, we talked about it. Anytime you want to expand, right? You want to add more servers, you want to add more compute, you want to add more storage, you can do it. As soon as you're done with your work, you can bring it down, right? You can bring it down to 0. That kind of elasticity you get only on the public cloud. Innovation. Most public cloud vendors today are providing state-of-the-art services. We will see what are the different kind of services available. I'm just going quick time check. All right. So you can innovate faster because it provides a lot of services. The state of the art, the current, whatever technologically advanced services are available, this is all provided as a service in cloud. So you can innovate faster and deploy globally. This is another very important point, right? Like if you have your own data center, let's say you're based in Virginia. You're based in Virginia, that's it. Like, let's say you have a client tomorrow who is sitting in London. You cannot go build a data center in London, right? To work with them or to provide a service to your client. But in cloud, it is possible because this vendor who is providing this service for you, he's established globally. They have presence in most regions, most cities. So when you decide that, okay, I'm going to expand my business to another country or another continent, maybe, all you have to do is they already have the infrastructure. You just have to spin your VMs there, and voila, you have deployed it globally. Your footprint is now global. So these are unmatched benefits that you get out of cloud. So functionality wise, we talked about elasticity. It's a shared infrastructure. When we talk about shared infrastructure, there is this big question about security, right? The same hardware may be running multiple VMs, but accessing those VMs are all going to be through the same infrastructure path. So, that's a very obvious concern, right? Like, what about security? When I was running in a private cloud, it's all my hardware, it's all my infrastructure. Nobody else is going to be exposed to my data. But when you're in public cloud, what about security? So there are a lot of things the public cloud vendors do, and security is the most important thing that they take care of, because that is the most important concern any customer is coming in with. So not just providing a shared infrastructure, they will have to have the necessary technology and software written to make sure that each and every other customer, they're completely isolated from each other. No one customer should be able to hack or look into the data that is being used or in transit through the public cloud. So they take care of that. That is one of the important functionality on a public cloud. Load balancing. Load balancing, I think you're familiar with the term. Load balancing is nothing but you get a single input. Let's say you're running a web server, okay? let's say like you're running Amazon.com or something, Flipkart or something, right? So you will have thousands of customers accessing your web server at any given point of time. If you put one server serving all these customers, it's not going to work, right? It's going to just break. So what you could do is you can put hundreds of servers, but you cannot give hundreds of URLs or hundreds of access points to all your customers. So you have to provide a single input connection, input URL or single input for all these accessing all these different servers that are sitting. So what you do is you put a load balancer in front of it. So any customer that is trying to access this application, they will first hit the load balancer, and the load balancer makes sure, or it takes the responsibility of splitting the traffic to all the different computers that are sitting behind it. That is another important functionality cloud offers. Serverless, that is the newest trend. Like we all talked about computer, what are the different basic building blocks and all that stuff. But the future is serverless. It's like why do I need to have a computer? I need an application, okay, fine. But why do you have to bring up even a VM for that? Because bringing a VM means you have to put an operating system on top of it. And then you have to patch this operating system regularly, make sure there is no security vulnerabilities happening in that particular VM. Not just that, you'll have to make sure your runtime environments, everything, like it is all applicable, works with application that you're building on top of it. So a lot of things, a lot of management, mundane tasks that are there. So what serverless does is, you don't even have to worry about, you don't even have to think that there is a computer doing all your job, okay? You just spin up, you just call. There's something called Lambda in Amazon world, which kind of provides this serverless functionality. What it does is it's just a simple code. You just call that code. What the code does is it spins a computer on back of it, but you're not aware of it. All it exposes to you is whatever amount of compute you're asking for, whatever amount of memory you're asking for, whatever amount of storage you're asking for. It is just going to expose that to you. All you have to do is use that, do your application. You don't have to worry about the computer that is sitting on beneath that. So that is another technology, and another important factor is high availability. When you talk about cloud, personally, I think this is one of the biggest feature a cloud can provide a customer, which they don't get in the traditional on-premise environment, is high availability. Let's say you're having one server, the server fails, right? Okay, you can then point it to another different server which is running as a backup. Okay, everything is backup. Let's say your data center got fire. Okay, what will happen? What will you do at that point? Okay, if you have another data center, probably you can point it to the other data center. Okay, great. But that means you'll have to run two different environments in parallel, which is again double the cost, which I don't think any company can afford for an efficient utilization of whatever resources they have. So they don't do that. But in cloud, what they do is pay as you go model. The infrastructure is already there, right? What you can do is you can spin up two different environments, like an active and passive environment, in completely two different regions. When I say region, it can be two different countries. Okay, even if you get an earthquake, you're not going to get it at the exact same time. So it kind of protects you. It provides that isolation, complete isolation from any kind of disaster that you might be. So if one region goes down, you can still point to the other region and continue running it. It's called as business continuity. That is something that there's the biggest functionality you get out of a public cloud. And then we talked about VDI, desktop virtualization, even before. It provides that. And content delivery network, that is another important or interesting concept, I should say. We talked about global availability for public cloud, right? So let's say I have a presence in Virginia, and I have another presence in India, let's say, okay, completely two different parts of the world. Now I'm hosting an application which is primarily running on Virginia. Okay. Now, users in India, they want to access this application. Okay. Typically, what will happen is, of course, you cross through the internet bandwidth, you connect to it across the globe. And obviously, that adds a lot of latency, poor performance. You get everything because you're connecting from two different parts of the world. Let's say you're accessing a web application. So the images, let's say it has tens of hundreds of images. Every image to download it, it's going to be like as if you're sitting on a dial-up connection. So instead, what this public cloud is providing is something called as content delivery network. What it does is it creates pops. It's called pops or edges across the globe. So what happens is, let's say a user in India tries to access a web page from an application that's running in Northern Virginia. The first time he accesses it, like it takes all the content for that web, the bits, right? The 1s and 0s. It picks everything and puts it on an edge that is closer to India. Okay, the first time it's going to be slow, it's fine. Let's say another user in India, he's trying to access the same web page. At that point, it recognizes that this user is sitting in this part of the world, and it'll see what is the closest edge that is there. And instead of going all the way to the origin in Virginia, it picks the content from the pop-up or the edge that is very close to India and give it to it. So he's going to get it like as if he's accessing it locally. So this is the base of content delivery network. Many cloud providers, they provide it as one of the functionality, but there are specific vendors who provide a content delivery network exclusively. They may not be a cloud provider, but all they do is they just create edges and provide the content delivery network. Akamai is one of the vendor who is very popular for CDN. All right. So we're talking about cloud. Another time check. We're talking about cloud. There are 3 different kind of service models that are provided by the public cloud. This is also important to know. So the base or the first or the one that makes sense, obvious kind of service is infrastructure as service, the bottom one, right? Typically, who uses it or who can use it efficiently for the kind of job that they do is system administrators. We will talk about it more. And then the next type is platform as a service. This is typically used by developers. And then there is something called software as a service. Okay, this is something that is used by an end user who does not even have to know programming or any kind of administrative system admin task, anything. They don't need to know anything. They just need to use that software. That's it, right? So let's start talking about infrastructure as a service. In this particular case, the provider is responsible for providing the infrastructure only. They just provide the infrastructure as a service which any customer can consume. When we talk about infrastructure, what all it will include is, of course, the hardware. That's actual hardware that's sitting, the servers, physical servers and the networks, all the networking devices. This is all the physical hardware thing. Along with it, they also run resources like virtualization and all that stuff, servers, virtualization, networking. They take care of all of that. Anything on top of it, right? Starting from the operating system, like they can some providers provide operating systems. They also allow customers to bring in their own operating systems. Starting from the operating system up, everything is the responsibility of the customer. The provider is only responsible of the infrastructure. So that is that. Examples, right? Amazon Web Services is one of the leading public cloud provider, and they provide infrastructure as service. There are a lot of services they provide. If you have heard about it, there are services like EC2, S3, and all those things. They all come under infrastructure as a service. And there is iCloud. I'm sure you all know about it. If you have an Apple phone, you know iCloud. That is also an infrastructure as a service platform. There is Windows Azure. There's Google Cloud. There's a lot of such providers available. Platform as a service. So on top of the infrastructure, now they are providing a programming language execution environment on top of the operating system. They provide that to the customer. So taking that, what they can do is they can start, they have a platform to start building on top of it. You still have to code your application. You still have to manage the data on top of it, but you don't have to worry about the operating system or setting up the execution environment, whatever it is. There are a lot of environments available. You don't have to worry about all that. It is available from that level on, and then you can just take care of your applications. So that is platform as service. Examples with Amazon Web Services, there is a specific service called Elastic Beanstalk. It is a service. It's a PaaS service. Basically, it provides a platform where you can start building your applications on top of it. And then there is PaaS services provided by Oracle. Google App Engine is one of the PaaS service. So likewise, you have other vendors who provide that as well. Software as a service, this is very simple. We all have used this. Everybody of us have used Google Drive, Google Sheet, Google Word. I don't think anyone who have not really used it. So these are Gmail, these are all coming under software as a service. In this particular case, what happens is the vendor takes care of everything, right? Like in terms of they take care of the hardware, operating system, they even take care of the application on top of it, right? And then they provide the software as a service, meaning all you have to do is just start consuming it. You don't have to develop anything on top of it. You just have to start consuming it for whatever needs you have. So we already saw some examples. Salesforce is another example, and Microsoft Office 365. These are all different examples from different vendors. We talked about this. It's just in a good picture format. As you can see, the first one that says on premises, everything go from the bottom up, right? You have the networking, you have storage on top of it, servers, virtualization, operating system. There's middleware, runtime environments, data, applications. Everything is the responsibility of the customer, right? Whoever is using it. And then when we come to cloud, the first form of service that is available is infrastructure as service. In this case, up to the operating system, networking, storage, servers, virtualization, operating system is taken care of the vendor. Sometimes the customer is allowed to bring in their own operating system, so they can do that. Anything on top of it, the customer is going to be responsible of. On the platform as service, only the top, the application part and the data is nothing but whatever you're running, using to run your application with. So you're only responsible for that. Everything under that is a responsibility of the vendor. On the software as service, everything up to the application layer is something is provided as a service. You just have to start consuming. Cloud. So I'm sure by now we talked about a lot of things with cloud, so you have a good idea of what cloud computing is. Let's see what are the different applications people use cloud computing for. Web applications is the most obvious one. End user computing is what we talked about. The desktop virtualization and all these things are end user computing. Internet of Things, IoT, is another technology that you will hear a lot when we talk about cloud. What IoT is, in very layman terms, is that Internet of Things. What it means is everything today. You say you have Fitbit, right? It knows, like, wherever you go, it knows what you're doing. How is this all possible, right? There's like let's say monitoring missions, right? You have we are driving through a toll. There is a camera sitting there. You have millions of cameras installed across the country. Okay, it takes a picture. How does this all connect, right? Everything connects to one central system. How is this How is this possible? This is all because of this IoT technology. What IoT does is it has devices, multiple millions of devices that are installed across, and they all collect data at wherever they are installed on. They collect data and they push all this data to one central point. So this platform or the framework should be capable of processing all the data that it is collecting from all these devices across the region, across the zone. That technology, all the framework, the application, everything that's driving this is called as IoT. And then game development, I'm pretty sure you all know about it. You all are experts in video games. Cloud gives a great platform for people who are interested in game development. Whatever amount of processing power or memory or what a processor is the biggest requirement for any kind of game development. So whatever kind of resource requirement you have, you get it readily on cloud. Media services, you all know there's in this COVID time, we all are watching Prime, Amazon Prime, Netflix. All these are running on top of cloud. Okay, they are not running on a data center. I mean, they are running on a data center, but it's all from the cloud provider. Media services is another big thing. Mobile applications. You can develop a lot of innovative mobile applications on cloud. Artificial intelligence, machine learning. Just a quick example. Let's say you're going to Amazon and say you want to buy a nice dress. Okay, a particular color, particular pattern, whatever, right? You search for it. You pick something. You look into it, and then at the bottom you will see related items, right? It provides a list of things that are very related to the search that you just did. How is this possible? This is artificial intelligence. It is taking the data and then it is running through a humongous amount of data that is stored elsewhere. It tries to make meaningful inferences based on the search that you did, and it provides suggestions to what you can do, right? This is artificial intelligence, just an example of it, but there's a lot of artificial intelligence examples that you can provide in Navy, in Army, in nuclear. There's a lot of things that you can do with AI and machine learning. And big data analytics is another big technology in compute. So when we just referred in the previous example, we talked about data. Data is the biggest in today, right? Today, data is the biggest challenge, I would say, in a way, because so you have internet, you have the capability to collect humongous amount of data through various platforms today, right? It can be through e-commerce, or it could be on internet, or it could be the IoT. You have data, you have lots and lots of data. It is the biggest challenge how to process these data. You have a particular question based on the data, how do you get it, right? So there is this technology called big data, and primarily its focus is, I have this, large, humongous amount of data. How do I process it? How do I efficiently process it so I can use it for my business? So that's big data and analytics. Blockchain, some of you are aware of it, or most of you are aware of it. Cloud provides a very good platform for the blockchain framework or creating the blockchain network itself. Robotics, it's also one of the things that you can use cloud. So as I mentioned in the earlier slides, cloud does provide a lot of ways to innovate. It says it makes sure you don't have to worry about anything infrastructure related, operating system patching. You can just forget about the whole thing and just focus on innovation. Whatever you need to do, whatever you need to create a breakthrough, you can just focus on it. So that's what cloud is providing you. That's the beauty of cloud. There's a lot of companies that use cloud. I would say 80% of the companies, at least at some capacity, they are using cloud today. These are all examples of some startup companies that are using cloud, and there are large enterprise customers. Just probably whatever I'm presenting is probably not even 10% of the customers that are using cloud today. It's just to kind of give you an example of, you might not have imagined, oh, these customers are using cloud. Yeah, I don't know that. Any big company, you think about it, they are all running on cloud, at least in some capacity. Either there are some enterprise customers who are cloud native, in the sense that they run all their businesses on cloud. There are some customers who are running in a hybrid model, where they run half their workloads in cloud, half on premise. And I'm pretty sure there are not many companies that are running on a data center or an on-premise capacity today. So that is all I had today to talk about. I didn't do too bad with my time either. So any questions?
Wow, Sudha, this is a really great introduction, very descriptive, and it helped us understand the makings of cloud. It looks like there's a lot working together to make this happen. So you also walked us through various applications of cloud and technology we have in mind. So we kept making questions during the presentation, and you almost answered all of them while presenting. Thank you so much. But
That's awesome.
we do still have some questions, so I'll just get started with asking you a few. So what would you recommend would be a starting point to learn about cloud technology, and what are the different aspects we could get started with learning?
Learning cloud technology. So it depends, right? It depends on what role you're in, right? Everybody in some capacity they're using cloud today. If you want to be a cloud provider, or let's say you want to be a facilitator of the cloud, you need to focus on. You shouldn't. My recommendation is you do not start. Okay, I'm going to start from the cloud, right? That doesn't work. So you need to focus on whatever technology that drives the cloud. You have to focus on that technology first, learn it completely, and then how you use that on cloud is how you get. Like, for example, right? If you want to be a security person, okay, you learn about security, all the different ways and all the different nooks and corners of security. You learn everything, and then when you come to cloud, you just apply that security on top of it. There's nothing about learning cloud technology. Cloud is just a platform, right? So you have to decide what you want to do. If you want to be a developer, right? Then okay, I develop programs. How do I develop it on cloud? It's very simple. There's not some lot. They have something called as APIs and cloud APIs that you need to use to interact with the cloud. There's let's say you're a Java developer. Let's say you know how to use Java. All you have to do is you have to understand how Java programming is defined for that particular cloud provider. That cloud provider provides you with all the APIs. You just need to brush up on the APIs and how exactly to plug in your script into the cloud. You just need to learn that. So it's not big deal, I would say, in a way. You choose what you want to do. You become an expert in that. And how you apply that in cloud is, there's a lot of materials available online, training courses available. You can go through that. And I'm saying that is not the biggest challenge. You focus on what you want to do, and then applying it in cloud just comes with minimal training, I would say.
So it's more of an enabler, and it's like a less steep learning curve?
Yeah, you need to, if you're a cloud developer, you need to understand how cloud operates. That's it. Okay. And what kind of APIs, what is different? What is different in using your script there? It's definitely different, but learning that is not a big deal. As I said, like, you just go through the documentation for that and you should be okay.
We had a question in the chat. They asked, is cloud both software and hardware?
Yeah, it does. We talked about infrastructure. We talked about various layers of software on top of it. So it is a bundle.
What does the future of cloud technology look like?
Cloud is the future. Let me put it that way. what is going to happen is there is going to be a lot of innovation on the cloud, right? Today, there's a lot of feedback. So today, there is a breakthrough technology or let's say a breakthrough application or a tool, whatever you are building. Today, nobody builds a tool which is not cloud compatible, okay? Because they all know that cloud is the future. The future of cloud is more and more innovation, making things easier for people. Um, you are the future, so you guys are going to make it a lot more innovation. I think innovation is what is the key for cloud future.
How does your job interact with cloud technology?
I am a technical account manager. Um, I basically support. We have something called as enterprise support for largest of largest customers who are using AWS. We have this account manager privilege for them. So my role is to make sure that enterprise customer is successful in AWS. That is all is my thing. If there is no bucket list of things that only which I need to take care of, I need to make sure this customer. So my customer is VMware. They're providing a SaaS platform called VMware Cloud on AWS. That is what they're doing. They are in a way a partner to AWS as well. So my job is to make sure VMware is very successful on top of AWS. It can start from anything around how they are operating today, how I support. They have an issue, they have a bug, they have a new feature request. They're doing a new innovative release, right? They're coming up with a new thing. How do I support it? So I talk to them with product discussions, feature requests, how you can make things better for their customers who are using that SaaS platform, how we can make things better. So whatever they already have, the architecture support everything, along with the future, whatever they are planning to do, how we can help them. So end to end, I support them. So that's my job.
I know you mentioned something about making servers available. How would you do that? Is it a program or so that we write, or is it otherwise?
Serverless? Are you asking about serverless?
No, I'm making a server available, like on the cloud.
Service or server?
Server.
I don't know the context. Uh,
Server space.
sorry?
Okay.
So
Context.
there isn't anything called making a server available, right? Like anything and everything that is running on top of a cloud is a virtual entity. Okay, it's a virtual machine. You use it as a server or whatever you want to use it as. It's completely up to you, right? So all the cloud is providing you is a virtual entity. A virtual. It can be a virtual machine, or it can be a virtual code, it can be a virtual functionality, it can be anything virtual. How you use it is completely up to you. It doesn't provide anything, okay, server. So it's just a virtual machine. You want to use it as a server, okay, you want to make sure it has a lot of CPU, a lot of memory to make sure that whatever functionality it is supposed to run, it can efficiently run. So any server is or a client or whatever it is just a virtual machine on top of cloud.
Is the cloud system safe and secure, especially for government and financial transactions?
That's a very good question. So when I talked about one of the functionality about public cloud is obviously, the isolation, how a customer environment is isolated from another customer is one of the important things. They do a lot of things to make sure that happens. I think the scope of the talk, we cannot talk about it, but they do a lot of things in terms of firewalling, policies. They use a lot of things to make sure that one customer data is not visible to another customer, right? Encryption, there's a lot of things that they do. However, right, when it comes to government, especially federal contracts, the data is very sensitive. Okay, so they do not or they cannot operate on the regular public cloud. So some cloud providers, like major cloud providers, like for example, Amazon Web Services, because that's where I work, provides two different types of cloud. One is the consumer or commercial cloud, which we all can use and which is all exposed to anybody and everybody. And then there is another type of cloud which is called a secret cloud. They call it as MVP cloud in Amazon, but that's not an terminology that is used typically. You can consider this as a secret cloud. Only federal or people who are government, only they can get access to that. Okay, there's a lot of formalities. You have to go through certain clearances. There's a lot of formalities. Basically, let me put it that way. So typical users of this secret cloud is only people like Navy, Army, government, any kind of federal. They are the only consumers of it. A regular user cannot access this cloud. So this is another layer of protection a cloud provider can provide.
Let me check if we have any more questions in the chat really quick. Ms. Sudha.
Sure.
Okay, I think that's all the questions. So thank you so much for talking to us, Ms. Sudha, and thank you for taking all our questions. We're really glad to have you here.
Thank you. Thanks, everyone. Bye-bye.